Weather is Earth's atmosphere in motion. Heat, moisture, and wind constantly reshaping the air above us. Uneven solar heating warms surfaces differently, building temperature contrasts that start the whole engine. Those contrasts create pressure differences, and air moves from higher to lower pressure, what we feel as wind. Add Earth's spin and paths curve, the Coriolis effect, turning broad flows into swirling highs and lows. When air masses meet, fronts form. Lifting along fronts builds clouds, rain, and sometimes storms. Clouds begin when rising air cools to its dew point. Vapor condenses on tiny particles called nuclei. Puffy cumulus, layered stratus, feathery cirrus. Cloud types hint at the processes shaping the sky. Raindrops grow as droplets collide. In colder clouds, ice crystals steal vapor and fall as snow or melt to rain. Radar sends out pulses and listens for echoes, mapping where precipitation is and how it's moving. Satellites watch from above in visible light, infrared, and microwave, tracking clouds, temperature, and water vapor. Balloons called radiosondes sample wind, temperature, and humidity through the depth of the atmosphere. Buoys, ships, aircraft, and thousands of surface stations feed the world's weather database every hour. All that data is blended, assimilated into starting states for powerful numerical weather models. Models solve physics on a grid, stepping forward in time to estimate winds, clouds, and temperature. Forecasters run ensembles, many slightly different starts to show probabilities and avoid overconfidence. For the next couple of hours, they blend radar trends and high-resolution models for sharp nowcasts. Thunderstorms need warm, moist air, lift, and instability. Strong wind shear can organize them into long-lived beasts. Hail forms as embryos loop through updrafts, gathering layers of ice like tree rings. In supercells, a rotating mesocyclone may tighten into a tornado. Doppler velocity helps spot telltale signatures. A watch means conditions favor storms. A warning means danger is happening. Take action right away. Hurricanes draw energy from warm seas, organizing bands around a calm eye with fierce eye walls. Impacts include wind, surge, and flooding rain. Forecasters share cones for track and separate outlooks for water. Outside the tropics, mid-latitude cyclones ride along fronts, steered by fast rivers of air called jet streams. The jet stream meanders in waves, guiding storms and setting temperature swings days in advance. Atmospheric rivers are narrow fire hoses of vapor that can deliver huge rain and mountain snow. Monsoons flip wind patterns seasonally, shifting dry and wet periods for whole regions. Cold air over warmer lakes churns moisture into snowbands, lake effect that buries narrow corridors. Cities run warmer at night, the urban heat island, affecting storms, air quality, and energy use. Fog forms when air cools to saturation or moist air moves over a cold surface, radiation or advection fog. Dew point tells how much moisture is present, relative humidity compares it to the air's capacity. Daily temperatures rise after sunrise and often peak mid-afternoon. Clouds and wind can shift the timing. Chance of rain usually means the probability precipitation will occur somewhere in your forecast area. Uncertainty grows with time. Cones show likely tracks, not the size of a storm. Always check hazards separately. Patterns like El Niño and La Niña shift storm tracks seasonally, nudging rainfall and temperature odds. Forecasters track drought with rainfall deficits, soil moisture, and evaporative demand indices. Air quality forecasts combine weather with smoke or ozone chemistry to warn sensitive groups. Space weather dances as auroras, but your daily forecast mostly rides winds, moisture, and terrain. Remote sensing measures snowpack and soil moisture, key inputs for spring flood and water supply outlooks. Hydrologists couple rainfall forecasts with river models to predict crests and issue timely warnings. Mountains force air up, shaping winds, waves, and rotors. Aviation and hikers watch these carefully. Coasts trade land and sea breezes daily as land heats and cools faster than water. Practice safety first by drinking water in heat, never driving through floodwater, and when thunder roars, go indoors. To read a forecast, skim the discussion, watch loops, and note confidence. Icons are summaries, not the whole story. You can help by sharing measured rain and snow with citizen science networks that feed real forecasts. Weather is physics you can feel, chaotic but understandable, made clearer by instruments, models, and many eyes on the sky. Like, comment, and subscribe for more videos like this.